Hello, this is the luckiest maths teacher in the world. Thank you so much for watching as we go through the gradient-intercept form. So what does this actually mean? Well, we're talking about linear equations. Remember, an equation is just something with an equal sign, and a linear equation is something that when you graph it, all the points lie in a straight line. So they're straight lines, okay? So any linear equation, doesn't matter what it looks like to begin with, any linear equation can be written in the same form. It can be written in the form y equals something times x, I'll just call that m, plus something, okay? So if it can't be written in this form, when you graph it, it won't be a line. And we're not concerned with those kind of equations in this part of the course. So y equals mx plus b. Now, I didn't just pick m for any random reason. I picked m because when it is in the form y equals mx plus b, the number in front of x, m, is the gradient, which we've looked at for a couple of lessons. So m is the gradient and b is the y-intercept, okay? Now this only works when the equation is in the form y equals something. Y has to be the subject of the equation, all right? So for example, let's say I have the equation y equals 2x plus 1. So this is definitely a linear equation because it's written in the form y equals mx plus b. So the number in front of x there is 2. So the gradient of this line is 2. The y-intercept is 1. That means if I were to graph this, it would hit the y-axis at 1. Let's say I have the equation y equals minus 3x plus 5. So the gradient is the number in front of x, this time minus 3. And the y-intercept is 5. Okay, so this one would hit the y-axis at 5. The gradient negative 3 means that every time you go across to the right 1, you go down 3. Okay, let's look at another one. Y equals, let's say, 4 plus x. Now this is written the other way around. It's still in the form y equals mx plus b because it's y equals something times x plus something. It's exactly the same as if I wrote it as y equals x plus 4 because it doesn't matter the order you add things. So here we know that the y-intercept is going to be 4. If there's no number written in front of x, the gradient's 1 because x is the same as 1x. If I have, say, the equation y equals 5, let's say 5 over 3x. Nothing wrong with that. Gradient can be a fraction. So the number in front of x now is 5 over 3, so that's the gradient. So if I were to graph this line, every 3 I go across, I go up 5. If the y-intercept's not written, it's not 1, it's 0. Because 5 over 3x is the same as 5 over 3x plus 0. Okay, so this one, y equals 5 over 3x, would actually go through the origin. The y-intercept would be 0. Okay, how easy is that? We just have to look at rearranging equations when they're not in the form y equals mx plus b. So please pause and copy this down if you need it. So let's say we have an equation like 4y minus 3x equals 24. Okay, so it may not look like it, but this is actually a straight line too, and it can be written in the form y equals mx plus b. As we did in a previous lesson, we can change this so it's in the form y equals mx plus b, and we do that by undoing everything that's been done to y. We make y the subject of the equation. So I want to get rid of this minus 3x, so I just treat it like a normal number. I add 3x to both sides. Then I get 4y equals 24 plus 3x, of course. Negative 3x and positive 3x cancel out. So this may look like it's in gradient-intercept form, but it's not because it's 4y equals something, not 1y equals something. So I need to do another step. I need to divide each side by 4. As I said in a previous lesson, when you're dividing something like this by 4, you need to divide everything by 4. So 4y divided by 4 is y. So I need to go 24 divided by 4, 3 divided by 4. Okay, so For this equation here, the gradient is actually positive 3 over 4, so that means every time I go across 4, I go up 3, and the y-intercept is 6. That wasn't obvious looking at the original equation. So let's look at another one. So if I have something like 2x minus 5y equals, let's say 10. Okay, please don't fall into the trap of saying, okay, the number in front of x is 2, so the gradient is 2. Well, that's not right at all. It's got to be in the form y equals something, so we have to rearrange it. So this time, I would subtract 2x. Now, y is negative. I want it to be a positive y, so I need to divide by negative 5, not positive 5. So 10 divided negative 5 gives me negative 2, and negative 2 divided negative 5, I get a positive. Okay, so for this line here, the gradient is actually positive 2 over 5, and the y-intercept is negative 2. That wasn't obvious just looking at the equation. So if it's not in the form y equals mx plus b, rearrange it, because you can always do that. You can always rearrange it into the form y equals mx plus b if it's a linear function, and we're only giving you linear functions in this part of the course. Alright, thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.